Hello students. Yesterday we had studied physical address used in segmentation of memory. The physical address was segment address plus index pointer. So we had seen that physical address was segment address into 10 plus instruction pointer. We have taken the example and studied it. Now what exactly is segment address we will see. Now let us see that in 8086 microprocessor we have 4 segments: ES, CS, SS and DS. ES stands for extra segment, CS stands for code segment, SS stands for stack segment, DS stands for data segment. Now, see, your 8086 microprocessor has 20 bits of address line, 20 bit address lines or 20 address lines, right? This means that it can address 2 raised to 20, that is 1 mega memory location. Now, there are two types of addressing mode. First, memory addressing. First is your linear addressing and second is your segmented addressing, as you will see in your notes. The memory segmentation are of two types: linear addressing and segmented addressing. Linear addressing we have seen in 8085 microprocessor, where the complete memory was accessible to the user as a single space. But in 8086 we have segmented addressing. What exactly is segmented addressing? We have a memory space from 0000 hex hex to FFFF hex. This complete memory location is divided in 4 segments: DS, CS, SS and ES. Each segment is of a length of 64 kilobytes. Each is having a length of 64 kilobytes. If you see the space in between these 4 segments are of 64 kilobytes. Now, what exactly is this concept? In the program, while using the memory, we can use different segments at the same time. How? The codes we are saving, we are putting in memory, the codes during programming is saved in code segment. The data needed to be handled is saved in data segment. The stack memory required is used in stack segment, and extra segment is used for storing the data, but mostly during string operation. When we are using string operation, we are using the stack segment. Now see, code segment executable program is stored. In data segment, data is stored. In extra segment, another data segment is stored, but this is generally for string operation, and SS stores the stack data. Now, this data is this address. Here we have seen the address of data segment as 2 4 times 0 to 2 4 times F. So this is 64 kilobytes. This address, base address 2 4 times 0, this address means from here to here, is stored in your data segment, because you have seen that in architecture that data segment is a 16-bit register. In architecture, see, in architecture we have seen that data segment is a 16-bit register which saves or which holds the starting address of your data segment, that is 24000. This is saved in your data segment. Similarly, stack segment, this will hold the address 5000 hex. Then what about your code segment? Code segment will hold 348A hex, and so on. Now, Now, there is a question, is this address which we have shown is fixed or can be edited? Yes, this was a question to me also. Now, this address can be edited by the user. User can fill the starting address or the base address. This is called as base address. This base address can be filled in these segment registers by the user also. But there are some conditions. The conditions are the starting address of any segment, or which is called as base address, should be evenly divided by 16. It is compulsory. Then minimum size of segment should be at least 16 bytes and maximum size of segment can be 64 bytes. Now, if suppose I don't wish to use this as 2000 hex, so I can start my data segment from 200F hex or 20FF hex or so on. Means this address should be divided by 16 and the minimum length I need to use of segment should be of 16 bits and maximum length I can use is of 64 kilobytes, not more than this. So this segment can move up or down. So we have some area, memory area, which is left blank between each segment register, so that this memory area can move up or down as per your programming. Understood the concept of segment register? I hope you have understood the concept of these segment registers. Instruction pointer will point to the next instruction to be executed, means this will add the content of instruction pointer. This adder will add the content of instruction pointer with segment address, base address into 10 and will give to memory, so that from there the code or the data can be fetched and put it in the queue. Clear?